Okay, welcome everybody. First order of business is to make sure you're in the right spot. So this is Catch Bugs Early with Apex Diagnostic Code. We're going to focus on some developer-centric stuff, a lot of Apex code, obviously. Thank you very much for coming. Second order of business is always this. This is not going to be an issue in this session. So we're not doing anything bleeding edge or future looking or anything like that. This is all old school help with writing better code. My name is Steve Cox, and I am a TA with a company called EnablePath. EnablePath is a Salesforce Gold partner, and I'm really lucky to be able to work on what's called the solutions team there, and we just focus on ways to make developers more productive and write higher quality code and create better quality Salesforce applications for our customers. So it's a nice position. This is my first time presenting at Dreamforce. And anybody know how to tell the difference between an introverted developer and an extroverted developer? Okay, so an extroverted developer will actually look at your shoes while he's talking to you. So that describes me pretty well. So my presentation skills are not the best, but I hope some of this stuff will help you in your work. You all, I'm guessing, are developers. Can I just see, raise of hands, how many are developers? Yeah, wow. How about technical architects or solution architects? Handful. Project managers. Yeah, there we go. Good for you. Quality assurance folks. Yeah, a couple. Great. Terrific. Okay, so mostly developers. This is the right mix, I think. So, and hopefully what you're after today is to find ways to find problems in your applications faster, to create custom code that's higher quality, that's more maintainable, and that's definitely what I'm passionate about, and that's what we'll be talking about today. To start off with a few definitions, these are some of the terms that are in the title of the presentation. Bugs, I think you're probably all familiar with, right? Anything that goes wrong in your software. It creates an incorrect result or some irregular data or whatever, right? And this can happen in any one of a number of stages. So if you read the column titles on the table there, requirements, architecture, construction, system test, post-release. So right, going from beginning of the project to the end of the project. And obviously when we say the word early, we're referring to where we are in that progression, right? And this table shows you just some real rough numbers on how much it costs to fix a problem that's found in one of these stages, right? So we'll be focusing on the bottom row, construction, where, as you can see, a bug found during construction, if we assign that the time of 1 for how long it takes to fix that problem, by the time you get to system test and post-release, you're at least an order of magnitude longer than that, right? You project managers know exactly what I'm talking about. Even I'm sure most of you developers, fixing something after it's been deployed, especially to production, is a headache, right? You got meetings, you got to invite stakeholders, you got emails all over the place, check-ins, code reviews, all kinds of crap, deployment to multiple orgs possibly, right? So it's expensive. And finally, diagnostics, you're probably familiar with in other parts of your life, right? You've got diagnostics that run on your car and diagnostics that run on your computer system, right? So anything, checks and tests and logging, any of these little things that help to validate that your software is running correctly. I'm talking about Apex code now. And it also can aid greatly in the maintainability, right? So can provide you instant regression checks on your code, much like unit tests do. Okay. Now, some of you may be saying to yourselves, there are no bugs in my code, right? I've known a few developers like that. There are no bugs in my code. So this is the first thing I want to convince you of. There are bugs in your code. There are bugs in my code, even the stuff I'm most careful with, right? Anything with any degree of complexity has bugs in it, right? I recall, I'm an old guy, when Microsoft Word version 2.0 came out, or maybe it was 3.0, Microsoft published their bug numbers. They had, when they released Word 3.0, I think it was, they had 3,000 known bugs, right? That was back in the old days. They don't even call them bugs anymore, or bug fixes, right? You get patches and you get enhancement releases and whatever their euphemisms are for bug fixes, right? But there are bugs in any software with any complexity at all. So, computer scientist named Donald Knuth, who wrote a lot of very important computer science texts back in the 80s, 90s. He was big into the C programming language and C++. Very, very meticulous developer and professional. Wrote several books with lots of sample code in it. And he is famous for having set up a reward system where he said, anybody who finds any problem in any of my books or sample code, technical problem, historical problem, grammatical problem, whatever, this guy was sure of himself, right? Anyone who finds a bug, I'll send them $2.56, right? Which is a hexadecimal dollar, 100 in hex. So, and this was pretty famous around the industry, right? And he gave out, I think, 2,000 checks over the next 15 years or so. $20,000 worth of checks. So a lot. A lot of people found problems with this stuff, right? And that was exactly his point. He was meticulous, he was careful, he had everything proofread multiple times, and still there were lots of problems in it, right? And as long as people look, they're going to find more problems in it. So that's kind of the point there. Third bullet point there are about 250 companies listed on this bugcrowd.com, which is a service which lets a company sign up and they say, anybody finds problems in our software or products or whatever, they just log it and they get money or they get, some kind of company bling or whatever, but they'll give them something. So, and all the companies you've heard of that you buy stuff from are on that list. So anyone who's in the know knows that there are problems in products and software continuously. Sorry, trying to figure out the system here. Okay, just going back to my last bullet point there, Salesforce. I've worked on some development teams, and I've had managers and project managers and TAs before who announced at the beginning of a project, every bug will be fixed, right? So now here's some ammunition for you. You can say, no, every bug will not be fixed unless we stop testing, right? So there will always be bugs, and it's important for development teams to know that and to realize that. You have to prioritize, you have to draw a line at some point and say, we got all the major things, we got all the showstoppers, and the rest, can be for further projects down the road. Okay, so hopefully I've convinced you of a couple things here. Bugs exist, they will always exist, and they exist in your code, in your team's code. And they're not a good thing. They cost a lot of money the later you find them, right? And so this whole notion of quality that we hear talked about has a lot to do with fixing bugs. So now the rest of the presentation here, I'll try to convince you that using diagnostics in your code is a pretty cheap and easy way to reduce the bugs, raise the quality, all that stuff. Okay, so the first one we're going to look at is a little thing called assertions. System.assert. Anybody ever used that function? Yeah. How many people have ever written that in code besides unit test code? Yeah. Oh, good. Yeah. We've got some old schoolers here. Some people who've developed in some other languages. So assertions don't only have to be used in unit tests. They're very useful in your regular trigger code or controller code. They can, just like in unit tests, they can be a point of verifying the correctness of your logic or of input parameters or whatever you want to verify at runtime. Assertions are also a great way to document your code. So if you're like me, documentation is not the most exciting thing, right? Assertions are a way to insert a little piece of documentation. This is the way this method should work, and if it doesn't work, I'm going to let you know immediately, right? So kind of alternative to documentation there. There we go. Okay, so here's a real simple implementation. And with all these little code samples I've got today, I'm sure you realize, most code is 100 times more complex than what you see in samples. So just keep that in mind as you try to visualize whether this will be effective to you or not. So here's a method, apply a new discount, and it's got one parameter, right, that's being passed in, a book. You can just ignore the EP, the namespace there for now. But this is basically doing a system assert, a couple of them. So first it's checking to make sure the book isn't null, and then it's checking that the price is not null and it's not negative, right? So this is a good example of a couple of ways to use asserts. If a problem happens in your code where, for example, book is passed in and the price is negative, right? So normally, if you didn't have these asserts at all, this function would not know, right? Goes merrily on its way, goes back to the caller, more code is run, maybe your data is messed up because now you got a negative price on a product, right? And nobody knows until somebody maybe sees in the UI that a price is negative and says, hey, this should never happen, right? So the best thing I can say about asserts here is you are notified immediately, right, when something happens. If you've got a comment as the second parameter of your assert, like I've got there, you will see exactly what went wrong, when it went wrong. And in this example, we're printing out the contents of the book object, right? So you'll be able to see right there in the UI exactly what happened. So it's much, much faster, as you know, than firing up the debug log, logging in as that user, running the test, going back to the debug log, trying to find within 30,000 lines of the debug log where your problem is. Much, much faster, right? So it can help out in how fast it is to debug your system and figure out what's going on. Okay, so here's another example. So another way you can use asserts is to check the object state. So this is a method on a class, right? You've got an Apex class, and within there you have this method. So one thing you can use asserts for is to check to make sure the object is in a valid state, right? So in this example, we're asserting that a discount is allowed, right, at this current time in this object. And if that fails and that method returns false, then we're printing out the value of this object. And hopefully you'll be able to see immediately what went wrong and why this method should not have been called when it was, right? Okay, the last example of an assertion is you can check the system state. So you may have things like this where, in the second line of the method there, we're checking the value of a custom setting, right? So now the new discount, in the last line of the function doesn't use it, but it should. The new discount is specified in a custom setting, right? Well, you can check right in your Apex code and make sure that has been set up correctly, right? So when you deploy your code to a QA environment or to production, you will know immediately or pretty soon that someone forgot to set up the new discount in the custom settings, right? So it's a good way to notify yourself of things like that. Second example there is, maybe running of this function is dependent on the permissions of the currently running user. You could check something like that, right? Okay, second example of, oh no, sorry, not there yet. All right, so one final point I wanted to make about assertions is you have to be real careful that you use them correctly, right? So just let's go back to this first example. So for example, what if you have a Visualforce page where the user is allowed to enter a price, right? And you don't have any client-side validation on that, and then this function is called to apply the discount, right? Well, in that case, this would not be a good idea, right? The user enters a negative price, and their page goes away, and they get that nasty, ugly-looking Salesforce assertion failed, right? Which you're probably not going to want to show to the user. You're going to want to have, an Apex page message show up that's nicely formatted. The rest of the page is still there, right? So don't use assertions where you should be using error handling instead, right? That's probably obvious. You want to make sure assertions, the point of assertions is to catch logic errors, catch programming errors. problems with your colleagues calling your method wrong, things like that, things that should never happen during runtime, right? Obviously, you'd never want to add an assert saying, oh, I'm asserting that this DML operation succeeded. You can't do that, right? Because DML operations can fail at any time for a multitude of reasons. So it's got to be for the right purpose. Okay, now we're moving on. Okay, second way, object validation. This is, anyone here ever use MFC? Oh, yeah. All right, okay, so back in how long has it been? Is MFC still around? You guys know? So it's a Microsoft, stands for Microsoft Foundation Classes, and it's a class library that Microsoft introduced to make it easier for developers to develop Windows applications, desktop applications. And they had some good diagnostic functions. They had an assert and a verify, and one called isValid, which I liked a lot. And isValid is basically there to validate the state of an object, right? A class instance. So as you can see here in the code sample, we have an isValid function, and we're just checking a couple of things. And the implementation of this obviously depends on the class you've written it for, right? But you'd want to assert there that, say at any time, this is what should be true about this object. We should have a valid ID. The running user should be, an administrator or whatever your criteria are. And then this isValid function can be called within the class, right, at the end of complex operations, just to check and make sure everything's still okay. If you pass instances of your object to other classes to run in different methods, those callers can call isValid to make sure they've received a valid object. When they give it back to you, it's still valid, stuff like that. So that can be useful, right? Checking the internal state of an object. Okay, one way to implement that and force the rest of your team to use it is the bottom one, right? An abstract class. Make all your Apex classes derived from something like this EP base class, which is abstract and doesn't declare isValid. And before they can compile their code, they have to add isValid with a body. And some of them may just return true, and then you can chastise them for doing that, right? But another example would be to do a virtual class with an isValid function. You can create a default that returns true or returns false, right? Returning false would force the developers to redefine that, override that method for each one of their classes and provide a valid implementation as well. So those kinds of things can make sure your code stays consistent and that you and the other developers on your team are using that functionality. Okay, programming by contract. Anybody heard of this notion? Design by contract, program by contract? Yeah. If you've worked in some other environments, this is a topic of conversation once in a while. Bertrand Meyer is the creator of the Eiffel programming language, and he's the one who came up with this notion. Eiffel has contracts built into it, so you create a method in Eiffel, you have to specify the contract, right? Here's what has to happen when this method is called, here's what we guarantee we're returning, here's what has to stay the same in between, that kind of stuff. So you have a client and a supplier, or, in our terminology, we would say this is a caller and a method, right? Supplier would be the method that you're defining. Contract is just like the usual sense of the word. Both sides have something they have to live up to. And the purpose is to validate, verify the data and the state. That, before your operation happens, everything's okay. After your operation happens, everything's still okay. Pretty straightforward, right? So you can implement this in Apex very easily. You can have 3 methods, which are really just renaming the assert method, right? Call them precondition, postcondition, and invariant, right? Then you can sprinkle your code with these, and it sets up contracts. So you can say, anybody in the future who wants to use this apply new discount method better pass in a valid book with a valid price that's not negative, right? And then at the end you can see we've got a postcondition. I'm going to promise you, Mr. Caller, that when you get this book back, the price is still going to be non-negative, right? So I'm going to guarantee that I don't have any overflows, that I'm not applying some kind of a negative discount that's going to create an invalid price. And then you may have an invariant assertion in there somewhere too that says, everything on this object is still valid, things like that. Okay, so once again, if you can imagine this method is 500 lines long, we've all seen those, right? 500 lines of Apex code. Then things like, a post condition at the end can be really useful, especially for a maintenance developer who comes in and says, now what is supposed to happen, right? What should be the return value of this? Something like this can be helpful. Okay. All right, so that's really all the diagnostic methods we really have time to discuss today. Another big one that I'm sure you're all familiar with is debug, right? The system.debug method. Debugging in Apex is not fun, right? If you've programmed in any other language in your life, you know that every other language has nice debug tools, right? I mean, even JavaScript, right? You can set breakpoints and step through code, and Apex is painful that way, right? I heard today, just this morning, there's a session on interactive debugging, right? I think with the tooling API, and Salesforce is working on some back-end stuff that's maybe going to start making it possible to have interactive debugging, stepping through your code. So, I'm glad I showed that slide at the beginning, right? Because that's kind of forward-looking. That's what I've heard. So anyway, a few reasons why writing wrappers around some of these functions is a good thing. There are lots of native Salesforce code that really can't be unit tested, right? Do you know how to unit test a debug statement in your code? You can't do it, right? I can't think offhand of why you'd want to, but you don't have access to where that information goes, right, in an Apex test. Same thing with assertions, right? If you have an assertion in your Apex code, not in your unit test, but in your Apex code, and that fires, what happens to your unit test? Out of there, right? You have no chance to catch that exception. Your unit test just fails. Even though maybe that's what you wanted to do, is make that assertion fail. So you just got to take it out, comment it out, whatever. So anyway, that's a problem. Second bullet point, you or someone on your team may determine that all this diagnostic code is fabulous and it's helpful in debugging and development, but we want it out of there in the production code, right? It's causing delays, it's causing performance problems, whatever the issue is, right? Other languages allow you to do that, right? Languages that have preprocessors, which is just about every other language probably. You can write diagnostic code in there, flip a compiler switch, pre-compiler switch, whatever it is, and it's gone magically, right? It doesn't show up in the production code. With Apex, you can't do that. But we can get around that by writing wrapper methods. And finally, customizations, right? So how many times have you had your code littered with debug statements, and you think, oh, it sure would be nice if instead of having to dig through these debug logs, it would just send me an email of my debug statements, right? Or send it to someone else, or especially after release, right after you've gone to production. So you can do that. If you have wrappers for these diagnostic functions, you can change how they work, right? You can do the regular thing, and then you can add stuff and make it customizable even in how you do your diagnostics. Okay, so we'll look at a few examples of that. This is a couple of wrapper functions for the debug function. And they work exactly the same as system debug, right? But the difference is you'll notice a few things. The second line of the class there defines a prefix. So without me having to dig through code and try to figure out which ones are my debug statements and which ones are, you can define that in some global way and then make it easier to find your debug statements, right? Third line of the code there, you'll see that we have a custom setting with an attribute called debugging, right? So with a custom setting, you can turn that on or off, and basically it disables the entire function, right? You'll see down here, if we check the flag, and if it's false, which it might be in production, right? We decided we want to turn off all our diagnostics, then nothing happens. All those debug statements don't do anything at all. You put the same thing in your assertions, and your contract methods and all that kind of stuff. So here's a similar example with assert, right? You can have a couple different functions. You can create overrides for all the different variants of assert and do the same kind of thing. These function exactly the same as system assert, but once again, it lets you have a little more control over how they work and even lets you turn them off. Contract methods, same thing, right? And these really are literally just syntactic sugar on top of the assert method. You're just renaming them. Okay? So that's about everything. I want to mention a few other things that are worth looking at. Salesforce Apex code is hard to debug currently. As I'm sure you guys know, it can be very frustrating. So learning some about the tools that are available can be a helpful thing. The debug log, there are some tricks there. You can do some filtering. You can mess with the levels, right? And do some different things, so that's worth learning about. Developer console is progressing all the time. Sometimes I think they spend more time on that than on the Force.com plugin, but for whatever that is. It's got some fairly nice tools. If you're familiar with the timeline, that is really useful, right? Shows you exactly how long your Visualforce code is taking versus your Apex code versus your DML statements. It can be very helpful, especially while profiling. Exception logging, this is a notion that we use at EnablePath. As you probably know, if you do future calls, batch processing, and exceptions happen in those contexts, what happens to the exceptions? If the Apex job, if you go to the Apex job page, sometimes you can see an exception, right, that happened there. But, you know, who goes and does that, right? Your customers are not going to go do that. Nobody but you is probably going to go do that. So it's sometimes hard because failures in those asynchronous contexts just get lost in the ether, right? So what you can do with exception logging, once again, create some default handlers or some wrapper classes that handle exceptions, and just always toss your exceptions in there, and then you can do whatever you want, right? You can send emails, you can create batched log files, you can write to Loggly, right, an external logging system. You can add rows to some custom object so you can do reports on them and stuff like that. You can do all kinds of stuff that's more useful than what Salesforce provides by default. And then finally, the scheduled unit test runs. This is another one we feel strongly about it at EnablePath. So we get in there as consultants and we do our work and we create this wonderful app. We say, here you go, customer, it's all yours. We're out of here, right? And then they get to struggle with all this. And a lot of bugs don't even happen until after you're gone, right? Scalability problems, performance problems due to more data, or minor configuration changes being made. They'll run into all kinds of problems after you're gone. If unit tests are running regularly, nightly, say, or weekly, then they're notified immediately when something goes wrong in the system, something unexpected, right? Or maybe as a result of your unit test, you email yourself, right? So you're notified, and you can call them up and say, hey, we noticed, there have been some changes in the system, or you're getting a lot of data, and there are some problems. We need to come in and take a look, and they'll thank you for it. They'll be very grateful. Okay, so in summary, like I said at the beginning, I'm really passionate about this stuff. I think it feels really good to feel like you're writing good quality code, you're producing good products for your customers. I think it frees up developers' time, right? So you're not spending as much time chasing down difficult to find bugs. You're spending more of your time doing the creative, fun, bleeding edge stuff, right? You're not spending all your time doing the mundane stuff that's so difficult in Salesforce. Your boss is obviously happier, your project manager is elated, your customers are obviously much more happy if you find these things early and get them fixed and provide ways to make your application a lot more maintainable over the years. Okay. All right, keep running into more slides. Here's some resources. In case you need more ammunition, if you've got folks in your organization who don't believe all this and they say, it costs too much to add diagnostics, right? I've heard that about unit testing. It costs too much. Don't do unit testing. Just get the bare minimum to get us to deployment. Well, if you can't convince them otherwise, here's some resources for you. Read some of these articles on assertions and contract programming. They're very persuasive. I've got a little bit of a blog going, which I'm not doing so well on lately, but I've written a couple of different tools, and I've made it all available to you. If you want to contribute, that'd be great. If you just want to use some of it. If you even just want to say, hey, that would be great. Okay, so got about 10 minutes. So we can do questions. I've got business cards. If anybody wants to chat further later on, you can come pick those up. Let's do a couple of questions. I think there are mics in the middle here. Yes, so let's do that.
I recently became a big fan of writing my own
Oh, about catching your own exceptions? No, it's a great idea, right? It's a great idea to create your own custom exceptions. You can do things like, track more information from the context, right? The built-in exceptions in Salesforce typically just have a description. So you can add, error codes and context information and stuff like that. That can be useful. And then again, if you handle those exceptions in a centralized way, that is also another thing, like I talked about earlier, where you can change how notifications go out about that exception. You can log them different places. So yeah, it's a great thought. Any other questions? Up here.
I have a question.
Sorry, I can't see that far back. Go ahead, since you got the mic. Sorry.
Have you tried integrating Splunk with Salesforce applications to make the logging better? And
All right. Start one more time.
have you tried integrating Salesforce with a Splunk to make the logging better and make the debugs easier?
Splunk. What kind of an application is that?
It's basically the log tracing application. So it takes care of all your logging based on the indexing. So it's a real-time logging. So once the application runs, you parallelly see all the logs traced.
Oh, yeah. Is that Salesforce's back-end logging system? Is that what you're talking about? No? External?
No. It's external, yes.
log. Okay, so like Loggly maybe. Yeah. If you use that, that's a great way to do it. Again, if you have some wrapper functions defined around debug or whatever, at EnablePath we have this notion of logger handlers. So we declare a logger interface, and the default interface just goes to system debug. But then within custom settings, you can specify the name of classes that implement this interface, and then go and log in whatever way you want to. So yeah, while you're debugging, you can say, okay, I need this stuff to go to Splunk. Go change your custom setting to add the Splunk class within your Apex code, and then that gets logged. When you're done, you disconnect it, and yeah, that's definitely possible with this stuff. Yep.
Thank you.
Thank you. Okay.
So the design by concept,
Right. Right. Yeah, good. So your question is, when using design by contract, or the assertions probably, any of that, right? Do you put it in your production code, or do you just leave it in the unit tests? And that may have been Salesforce's rationale have you ever seen an assert within production code in Salesforce sample code? No. I would defy anyone to find one, right? Written by Salesforce. It does not happen. So I think that is actually their recommended procedures to do that, to put all your assertions, all your diagnostic stuff in the unit tests. Yeah, I don't know. I mean, if you write great unit tests and you set up unit testing that can run after your team's gone, so it continues to check the code after you're done. Yeah, that's okay. I prefer to have stuff within the code itself. And like I showed you there, with a custom setting, you can turn it off at any time. So you get to production and you determine you don't want that stuff to run. Granted, it's not completely gone, right? You still are making the call to your wrapper function, but then just within a couple of instructions, it determines we're no longer debugging and it kicks you out. And it's really a very minimal effect. So I think I do provide, I prefer putting it in your regular code rather than in your unit tests. Okay, any others? Go ahead.
Can you give an example of object validation?
Example of object validation. Let's take a look at the book class, right, that we were doing. How fast will this thing go? This is going to be fun looking at YouTube. What's going on?
What?
I went past it. Oh, okay. So let's take a look at this one. So let's say we have a book Apex class, right? And this this method is a part of that. How's that? So instead of passing in the book as a parameter, this book Apex class has a book __ C object, right? And so maybe a real simplified example of an is valid implementation is you just want to make sure that variable is set up correctly.
I could have in mind with your an example with your super. I didn't quite see how does that work?
Super?
Super is valid.
Yeah, so if you've got an interface or an abstract class that all your Apex classes are derived from, right? Then maybe you have a bit of a hierarchy going, right? Maybe you have a book class, and then you have a textbook class, and you have a novel class. And both of those extend to the book class. Maybe the book has its own is valid implementation that tests itself, right? Make sure the book is valid. And then maybe each of those subclasses have further overrides that test a couple other conditions, right? So then when you run is valid on one of the derived classes, it's going to do its checks. And then if you call super is valid, it's going to make sure that its parent also thinks it's a valid object. So that's how I would imagine that. Make sense? Okay. 3 minutes to go if anybody has any final words. Thank you very much. Hopefully it was useful. If you want a business card, if you're interested in any of this stuff, I can send you all the code or whatever. So, thank you for coming.